Okay, so in this lesson, we're going to look at simplifying radical expressions, and we're going to call this part one because these radical expressions we're going to look at is not that difficult. It's going to be very simple. Part two is where it's not going to be as simple as these. So there's a couple more things you would need to do in part two. But before we can do part two, you have to understand part one. So basically, part one is going to look something like this. So I'm going to leave some space here. I'm going to come back and well, let's go ahead and do it. So number one, basically you're going to be asked to simplify each of the following. So simplify. All right. So number one is going to say the square root of x to the eighth. Square root of x to the eighth. Okay. So um, in a previous lesson, you learned about this fact. You learned about converting radicals to rational exponents and vice versa. Okay, radicals to rational exponents and rational exponents to radicals. So for example, if I have a to the m divided by n, you learned that's the nth root of a all raised to the m power. But we also can write it like this. See where we put the exponent on the outside? You could also write it as the nth root of a to the m power. And for these, that's what you're going to want to do. You're going to want to rewrite this as this. Okay? All right, so look at this right here. I have the square root of x to the eighth. So remember, when we talked about a rational exponent in the previous lesson, the denominator was your index, and your numerator was your exponent, either on the outside or on the inside. Does not matter. So if I look at this, your index here is 2, and your exponent is 8. So if I want to rewrite this as rational exponents, so going from radical to rational exponent, this becomes x to the 8 divided by 2. And so 8 divided by 2 is 4, so I get x to the 4th power. All right, now this is called part one because when we do these problems, you're going to notice that the exponent that we're going to have will be divisible by the index. So notice that I started out with an expression involving radicals to an expression that doesn't have any radicals at all. So that's part one. That's what we're going to look at here. In part two, you're going to start out with expressions that involve radicals, and you're going to end up with or without expressions that involve radicals. So they may or may not have radicals in part two. But part one they will, because the problems we're going to look at, the exponents will always be divisible by 2. So you're going to get a whole number as your exponent. The other thing I want to mention is this. There are situations where when you simplify these, you're going to end up having to insert absolute values. That's not going to be here. We're going to assume that all variables represent positive numbers. So we're going to assume all variables represent positive numbers because there are situations if it was any number that we would have to insert absolute value bars in some cases. But for us, we'll just assume that all variables represent positive numbers. That is another lesson, and it is in Canvas where you deal with absolute values. But these can be positive numbers, so that's all you do. Don't worry about anything else. You're done. All right, number 2. Suppose I had the cube root of x to the 15th power. Again, that's a very easy one. So I'm going to go from a radical expression. To a rational exponent. So this becomes, remember your exponent is your numerator, your index is your denominator. So it becomes x raised to the 15 divided by 3, which is x to the 5th power. All right, number 3, you have the square root of x to the 4th, y to the 6th, z to the 8th. The square root of x to the 4th, y to the 6th, z to the 8th. All right, so again, notice that the exponents are all divisible by the index. So when I write the answer, I'm not going to have a radical at all. So you're not going to see a radical. But I want you to remember this. You got to remember this idea to help you with this one. You know that the square root of 8 times 2, like this, I can write as the square root of 8 times the square root of 2. So if you have a radical, the product involving a radical, so the square root or cube root, fourth root, whatever it is, of 8 times 2, you can split into 2 radicals as a product of 2 radicals. I'm going to do that here. So basically what I mean is this, and you can skip some of these steps. So you'll notice, for the most part, when you become fluent, and you probably are fluent now, you can go from here to the answer. You can go from here to the answer just by saying 8 divided by 2 is 4. 15 divided by 3 is 5. You could do the same thing here. 4 divided by 2 is 2. 6 divided by 2 is 3. 8 divided by 2 is 4. But if you need to, you can go ahead and use this idea here. So this is the square root of x to the 4th times the square root of y to the 6th times the square root of x to the 8th. And so now let's simplify each of these radicals. The square root of x to the 4th is x squared, because 4 divided by 2 is 2. Well, maybe I should have rewritten it. So it'll be 4 divided by 2, just like this. And then here, that'll be y raised to the 6 divided by 2. And then this is x raised to the 8 divided by 2. And then your answer then would be x squared, y cubed, because 6 divided by 2 is 3. And then 8 divided by 2 is 4. Oop, that should be a y. X, y, z, sorry, z. Z, Z. All right. Now, I'm just going to remind you this, that, and we're not talking about this in here. This is in another lesson, and it is in Canvas. But for us, we're just going to deal with positive exponents. But if your positive numbers for your variables. But if your variable could have taken any real number, then you would have had to, for this right here, you would have had to say x squared z to the 4th times the absolute value of y cubed. You would have had to say that. All right, but that isn't that is something that we're not talking about in here. So don't even worry about this. We're just going to assume that all the variables represent positive numbers. In this lesson, we're not worried about this. This is your answer. You're done. But again, I need for you to be able to go from here to here for these problems because they're not that difficult. Go from here to here very fluently. 4 divided by 2 is 2. 6 divided by 2 is 3. 8 divided by 2 is 4. Okay, number 4. Suppose I had the cube root of 64, x to the 9th, y to the 18th. So the cube root of 64, x to the 9th, y to the 18th. So again, if you need to split it apart, you can. So it'll be the cube root of 64 times the cube root of x to the 9th times the cube root of y to the 18th. And so the cube root of 64, that means, now notice this is a number, so you got to think of this a little bit different than these. So cube root of 64 means what number times itself 3 times, what real number times itself 3 times is 64. So the answer is 4. So this right here is 4. And then this becomes x to the 9 divided by 3, y to the 18 divided by 3. So remember, your index is your denominator. So you're going to convert this to a rational exponent. And so you get 9 divided by 3, 18 divided by 3. And so your answer then would be 4x cubed y to the 6. 4x cubed y to the 6. All right, number 5. So suppose in number 5 you had this. You had the cube root of negative 32 y to the 5th divided by x to the 20th. cube root of negative 32 y to the 5th divided by x to the 20th. All right, so again, if you need to, you can rewrite this as the cube root of negative 32 y to the 5th divided by the cube root of, I'm sorry, that's fifth root, excuse me, fifth root. The fifth root of x to the 20th. All right, so that's fifth root. Okay, so in the numerator, let's talk about the numerator. So the numerator I can write as the fifth root of negative 32 times the fifth root of y to the 5th. The denominator I can write as, well, it's only one thing, so I'm just going to leave that alone for right now. So I'm just trying to make these the same as these. So this becomes, now remember the fifth root of negative 32, you're going to do it just like you did this one. So what number times itself 5 times is negative 32? All right, so the answer is negative 2, so that's negative 2 right here. And then here, remember that means the fifth root of y to the 5th means y to the 5 divided by 5. And then here, the fifth root of x to the 20th means x raised to the 20 divided by 5. And then let's simplify this, and so your answer then would be negative 2y, because 5 divided by 5 is 1, divided by x to the 4th power. All right, so that was the idea behind part 1. So these are not difficult situations to deal with. You should be able to do this. So just real quickly, let's do one more before we stop this lesson. So suppose I had the fifth root of, let's say, so let's say 243 x to the 15th power y to the, that's 243 here, 243 x to the 15th power y to the 10th divided by, and let's say this was z to the 25th. All right, so again, just using this idea, you're going to say that's going to be the fifth root of 243 x to the 15th y to the 10th divided by the fifth root of z to the 25th. So at this point, though, what you can do is skip a lot of these steps. So at some point you should be able to do this. So the fifth root of 243, you're going to ask yourself, what number times itself 5 times is 243? Now, for some of you, you may need to use your calculator. So let's talk about using a calculator with this. Okay, so let's talk about how to use a calculator to find the fifth root of 243. So remember, this is the calculator we're using. And so to use this calculator, you're going to have to, remember, trying to find the cube root of 243 using a calculator. So cube root of 243. So you have to, this is fifth root of 243. So fifth root of 243. So you have to press your index first. So your index is 5. So you got to do that first. Press 5 first. All right. So now right above the caret symbol, it's right here where it looks like a roof. That's called the caret symbol. C-A-R-E-T. I'm using the word caret symbol. In math, this caret symbol means raising something to a power. That's what that is. But in particular, I am interested in taking the fifth root. So right above that, in blue, just look at your calculator, you see this symbol. You see something like the x root right here. You see that symbol. So to get to it, you got to press your second button. All right, so you're going to say the fifth root, so you're going to enter 5. Then you're going to say second. So, second, and then the caret symbol. You see what shows up? So that x here, the index x refers to this. So this is the fifth root, and then you're going to enter your radicand. So our radicand is 243. So you can say 243 and then press equal, and you get 3. So the fifth root of 243 is 3. So that's what that is. So that's 3. So the numerator here will be 3. And then the fifth root of x to the 15th, so remember 15 divided by 5 is 3, so that's x cubed. And then 10 divided by 5 is 2, so you get y squared. Over. And then here, 25 divided by 5 is 5, so that's z to the 5th. All right, so notice I went from here to the answer very quickly. Okay, so if you want to go back and you want to do, let's say, the cube root of 64, let's do the cube root of 64 in the calculator. So to do the cube root of 64, remember you got to do your index first. You got to say 3. Go ahead and clear it. You're going to say 3. All right, so you got to go to your caret symbol, so the one that looks like a roof. So that's your exponent button right here. And so you're going to go second, though, and then press that caret symbol. And so now you see this index x, so that says you're taking a cube root of some number, and the number I'm taking a cube root of is 64. So type in 64, and then press equal, and you get 4. All right, and so that's what we had here. So if you want to do the fifth root of negative 32, so the fifth root of negative 32, so again, you got to type in 5 for fifth root. You're going to press second, then your caret symbol, so second, caret symbol, and then type in negative 32, just like this, and then press enter, and you get negative 2. Okay? All right, so that's how you can use your calculator if you're not quite sure very quickly how to find the cube root of 243. So just go to your calculator. All right, so that takes care of this lesson. So that's simplifying radical expressions, just like this. And so notice when simplifying these radical expressions, I converted them to rational exponents. So all these were rational exponents. At some point, though, these were easy enough to where you did not have to do all this work. You can go from here to the answer very quickly. You can go from here to the answer without doing all this work. At some point, you need to be able to do that. Go from here to here without doing the work. You need to be fluid with some of these. We also saw that we're going to assume that all these variables represent positive numbers, so I don't have to worry about absolute values. So at this point, you have no idea what I'm talking about unless you looked at that lesson, which we haven't done, but it is in Canvas if you want to. For us, we're going to assume that all these variables represent positive numbers. So notice none of these involved absolute values. All right, so that's the end of this lesson.